to length of a line segment. So let's just recall Pythagorean's theorem first. So if we have to solve for each unknown, of course we're solving for the x's. Okay, so Pythagorean's theorem is a squared plus b squared equals c squared. Okay, a and b are interchangeable, so we can write 5 squared plus 12 squared or vice versa. Okay, c has to be the hypotenuse, so it has to be opposite the 90-degree angle. Okay, so we get 25 plus 144 equals c squared plus 169 equals c squared. Okay, so c equals 13. Okay, or x. Should have put x. Let's put x for this one. Okay, a squared plus b squared equals, we're going to do x squared. Okay, 4 squared plus 3 squared, which is 16 plus 9, which is 25. Okay, that equals x squared. We root both sides and we get x equals 5. Okay, so the measurement of x for this one is 5. This is going to be in meters, and then the 13 is going to be in centimeters. Okay, so just a really quick overview of Pythagorean's theorem. You're going to see why that comes into play soon. Okay, example 1. Let's plot the points A and B. So negative 4, 3. So negative 4, 3 is going to be our A. And 5, negative 3 is going to be our B. Okay, and we're going to connect this as a line segment. So for A, what we want to do is we want to find the vertical, or like the rise, and the horizontal, which is the run. Okay, distance between these points. So this is very similar to what we did in grade 9. We just want to draw a triangle from A to B. Okay, and now if we actually count the number of, I want to say squares, or the number of boxes, only because the scale for x and y are both in ones, we can say 1, 2, 3, 4, 5, 6. So the rise is going to be a 6, and the run is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we actually don't know what this length is, like the line segment AB, but what we can do is now we can find it using Pythagorean's theorem. So let's do 6 squared plus 9 squared equals AB squared. Okay, I get 36 plus 81, and that's going to equal AB squared. AB being like the line segment. Okay, I get 127 equals AB squared. We're going to root both sides, and we can say the line segment AB equals 11 let's go 27 units. Okay, just a review. If we ever don't have centimeters, meters, millimeters, kilometers, whatever it is, we always put the word units beside. Okay, so what we just did is we plotted A and B, and then we used the rise and the run to actually calculate the distance between A and B. Okay, let's do a similar example. So let's plot C and D. So C is 5, 10. So 5, all the way up here. And D is negative 3, negative 4. Okay, and again, we're going to do the exact same thing. We're going to calculate the rise and the run. And you could have had this triangle look like this. That's fine. Okay, let's go ahead and calculate. So we start at C, 1, 2, 3, 4, 5, 6, 7, 8. I get for the run, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 I get for the rise. Okay, and again, so we're done that. Again, let's find the distance using Pythagorean's theorem. So let's do 8 squared plus 14 squared. This time we're going to equal CD, the length of CD squared. Okay, so 8 squared is 64, 14 squared is 196, and that's going to equal CD, the length of CD squared. Okay, I get 260, and then when I root that, I get Okay, so root both sides, I get 16.12 units. And that's going to equal the length of CD. Okay, same approach, use Pythagorean's theorem. So now let's actually take a look at a formula that we can use without counting boxes, because if we don't have nice and pretty numbers, we're not going to be able to count boxes. Okay, so here is our equation for the length of a line segment. The distance, so we use D for distance. Even though we call it length, we use distance. We know with Pythagorean's theorem, we're going to root something, right? So what we're finding is the difference in the x's, which is going to give us our run. And then we're going to add the distance in the y's, which is going to give us our, difference in the y's, which is going to give us our rise, right? And we're going to square them both, just like Pythagorean's theorem. Okay? So let's actually find the length of AB using this formula this time, okay? And this formula is not difficult. Where the difficulty may come into place is if we confuse any of these letters. So we know that this is x comma y. That's how we write an ordered pair. Okay, and let's call A, E, 0.1 and B 0.2. So this is going to be x1, y1, and then x2, y2. Okay, so let's subtract x2 minus x1. So negative 3 minus 2. Negative 3 minus 2. And square that. And now the difference in the y's. 5 minus 2. And just like how I have said before for slope, we just have to be consistent, okay? If we're using B as the first point, it always has to be B minus A. So the x of the B minus the x of the A, or the y minus the y, okay? The y of the B minus the y of the A. Just be consistent. So I get negative 5 squared plus I get 3 squared. So I get, and I'm rooting each time. I'm writing good math form, writing down the page, rooting. I get 25 plus 9. I get root 34. Okay, I'm lazy. I would leave it as root 34 units, but a lot of people are not comfortable with that. That's okay. 5.83 units. And 1 or 2 decimal places is okay. Okay, all I did this time was insert example 4 and example 5. So the exact same thing, let's use the distance formula to find the length with these two endpoints, A and B. So I'm going to do B minus A again. So the x is 4 minus negative 3. Be very patient on the brackets, and then bracket all the x's and square them. Okay? Y's, 5 minus 1, that's pretty easy. 5 minus 1, oops. And I'm going to bracket that afterwards and square it. Okay? 4, 5, 6, 7, I get 7 squared plus 4 squared. Okay, again, I'm showing the root sign. I get 49 plus 16. And for 49 plus 16, I get root 65. Okay, I'm lazy, I would leave root 65. A lot of people are not comfortable with that. 8.06 units. That's the length of the line segment with endpoints A, B. All right, and now let's try example 5. And you should be able to start to try these on your own. Okay, again, A, B. I'm going to do B minus A. That's a very common thing in mathematics, the backwards. Okay, 0 minus negative 3. 0 minus negative 3. Again, a double negative there. Okay, 4 minus 0. So I get 3 squared plus 4 squared, which gives us 9 plus 16, which gives us root 25. I'm not going to be lazy this time because it's actually a really pretty number, 5 units. Okay, example 6 is going to be a word problem, and this is exactly why we don't count boxes, because sometimes we're going to get ridiculously big numbers. Okay, so a helicopter ambulance picks up a patient. Okay, I'm just going to draw this P. Okay, so the patient's at 96, 107. The nearest hospitals that can provide the treatment that the patient needs are in Timmins. So let's say T is 200, 296, or Sudbury. And let's put dots here, which is 232, 80. Okay, which hospital should the helicopter take the patient? So we're going to have some sort of triangle connecting the patient to Timmins, and then we're going to have some sort of triangle connecting the patient to Sudbury. This is not drawn to scale. So let's find the distance between the patient and Timmins. Okay, we're going to subtract the x's. So when we write PT, we actually want to do T minus P. That's proper math form. So we're going to do 200 minus 96. Square that. Okay, we're going to go 296 minus 107. 296 minus 107. Okay, and then it's just calculating. 200 minus 96, I get 104. And that's squared. So in the next line, I'm going to put 10,816. And 296 minus 107, I get 189 squared. And the next line, I'm going to put 35,721. Okay, and I'm going to put roots on all of those. Okay, when we add them together, we get 46,537. Okay, if you want to root it, that's fine, but we're going to be able to compare these two numbers, because again, whatever the smaller number is, that's the shortest distance. So 215.72, okay, units. It makes sense in this case if that were kilometers, but it doesn't say in the question. Okay, now let's do the same thing. Let's do the distance between PS. Okay, so the patient in Sudbury. So again, because it says PS, we actually subtract backwards. We subtract S minus P. So we're going to go 232 minus 96. Okay, and then we're going to add 80 minus 107. And what do we get? Okay, for 232 minus 96, I get 136. And because I'm lazy, while this is already in my calculator, I'm going to square it and write it down. 18,496. Okay, and 80 minus 107 gives me negative 27. And that's okay if it's negative, because then when we square it, it's going to give us 729. Yeah, and when we add them, 18,496. I get root 19,000. So clearly right from here, we can tell that Sudbury's closer, but if you want to root it and that makes you feel more comfortable, this one's 138.65 units away. So we want to say, therefore, the patient should be taken to Sudbury. Okay, example 7. Find the length of the median from P for a triangle with these three vertices, P, Q, and R. Okay, so we're in this case talking about a median from P. So it's going to go from P to the midpoint of QR. Okay, and you can label these if you'd like. P is negative 2, 2, Q is 7, negative 1, R is 1, 5. So for the median, I would immediately find the midpoint, erase that, let's go capital M of QR. Okay, so average the x's, 7 plus 1 over 2, average the y's. Negative 1 plus 5 over 2. I get that's 8, so I get 4, and then that's 4, so I get 4 comma 2. Let's call that M, 4 comma 2. I thought this question was a lot harder, but we already have the point P, and we already have now the median. So let's just go ahead and calculate the median. So let's go the distance or the length of PM. That means we're going to do M minus that P. So the M coordinate is going to be first. 4 minus negative 2. 4 minus negative 2. We're going to square that. 2 minus 2. Oh, that's beautiful. Oops. Okay. 2 minus 2 goes away. That's just 0. Okay, so 4 minus negative 2, I get 6 squared. But then it's rooted, so those just cancel, and we get 6. Therefore, the median is 6 units. And that's it.